Hello everyone. We are currently in long mode and now we want to jump to kernel and write the kernel. So in this video we are going to write a kernel, a simple kernel that prints to the screen, and after that we are going to make a makefile to compile all the files and create a booting image, and then we will use QEMU to simulate the booting process. So let's start it. So after that, uh, so we were here. So I'm gonna fill some stack with the same AX. And now what I want to do is I want to jump to 0x1, and if that fails, we will just reload over here. Okay. Now, with that being said, our bootloader is completely fine. Now, we will make now something called a kernel, and sorry, I think I made a folder instead of a file. So let me delete it again and write a kernel.sm. So for the kernel, I'm gonna, because we are already in long mode, so we are going to use 64-bit instruction offset and everything, and the this will start at 0x1 to 3. Now that we have done it, first of all, what I want to do is I want to create a label that we want to print to the screen. So let me create a label called MSG, that stands for message. So I'm gonna define byte. So we need this to print to the screen, and at the last null terminator. So we are going to use a buffer. So how we can do that? You have to follow me in the code, then you will clearly see that. So first of all, for the source, for the register source index, I will fill the register source index with the address of the first byte of the message label, and then for the register destination index, we are going to, before printing to the screen, we need to print to a buffer called VGA test buffer address, and I have the address over here, and I'm gonna just copy it from my notes. 8000. Now that we have the source and destination, now we can start printing to the screen. So for that, I'm gonna create a label called start. One thing I forgot was that in the AH register, you have to fill the color that the text represent. For simple, I want to print green, and I know that for fact this 0x0a means uh, green character in black screen. So I'm gonna use ah equals to 0x0a. Now I'm gonna move whatever is in the register source index to ah, because whatever is in ah will be transferred to RDI and then printed. So move ah. uh no, I'm so sorry. I was actually talking about AL, not AH. Okay, so whatever content is in the RSI. Now I'm gonna compare AL with 0, and if that is 0, that means we have reached the null terminator. That means we will create a label called done over here, and then we will jump over here. In the done label, we will just clear the interrupt and we will halt. So if it is not the 0, we need to transfer it to the RDI. So move to RDI, uh, the content of AL, and after that we are going to increment RDI by, sorry, by AX, not because we want to fill both AH and AL with that. So move RDI with AX. Okay, RDI. And I think it should be move RDI inside this RDI pointer, inside the RDI index. And now after that, we are going to add RDI, we are going to basically increment RDI by 2 bytes, and then increment our SI, that is our source, by 1 byte, so that we go to the next character, and we are going to jump to the start label again. So that being said, I think this should look fine. And also let me place this instruction over here so that it is not executed. So now that we have done that, I think our kernel should be fine. Let me check if we have done any mistake. And I think, oh yeah, I think it should be like if it is equal, then only we are jumping to a done level. And uh, that is it. Only one conditional instruction bug. And after that, we are now going to write a uh, Makefile, so that we can compile and simulate the booting process. So for that, I'm gonna make a Makefile over here. And for Makefile, first of all, let me create a target, and the action target and dependencies will be run. And here, uh, we will use build and a tab of space, and after that we will use nasm slash dot, not dot, I don't know what do you call it, I forgot. So dash, so sorry, dash f, and we are using binary. So binary, oh sorry, bin, we want to make it binary. So our content is in source to bootloader dot asm, and we want to store it in binary slash bootloader dot bin. And also uh, we want the same thing happen with the kernel, so I'm gonna just copy paste it and just put kernel over here, and also kernel.bin. Now that we have done this, now we want to place this in like sector 1 and sector 2. So I'm gonna concatenate both of them using this cat command. So binary uh, and binary this boot bootloader dot bin with binary kernel.bin that we have already made will be binded with a new file called disk uh, dot img. Okay, now this is the file that the QEMU will use to simulate the booting process. Now we will create another target, and over here the dependencies will be built and tab space, and we will use the QEMU instruction. QEMU system x86 64, and then drive format equals to raw, and file equals to uh, binary dash disk dot img, and in the last part we will use a clean uh, target and use tab space and remove all the binary files if we use make clean. So binary slash whatever it is in the binary. So with this being said, I think our if we haven't made any uh, error in kernel.asm and in our makefile, this should first of all connect two of our uh, bootloader and kernel to load in sector 1 and sector 2 and then simulate the booting process. But first of all, let's use the make command over here, and here is an error. So we have found the mistake. The mistake lies in the line number, I think, 6, right? And line number 6 is right, and I think I have left over one boot a typo mistake that I make a lot. And if I save it and use a make command, now what we want to print to the screen is we need this to print to the screen, and it should be all in green. So if you do that, you can see that this simulated the booting process, but it is, although it is printing the line in the first a few lines of this simulator, but uh, it is printing to the screen. So we have successfully made a bootloader and a simple kernel and simulated how a booting process works. So now in the next video, if we make a video, we will make a cross compiler, and then we can write our kernel in C. But I see that journey uh, uh, long, so I don't know if I'm going to do that or no. But I will be making set. I will be making my own kernel, so it is all about time when I will start a new video. So for today, I'm gonna stop right here, and see you guys in the next video. And thank you.